Hi, I'm Larry Richards. I'm a professor in the Department of Mechanical and Aerospace Engineering at the University of Virginia. And for the past decade or so, I've been concerned with K-12 engineering outreach. At the University of Virginia, we develop engineering teaching kits. These are designed to integrate with current science and math classes, but bring the engineering design process into the classroom. Today we'll talk about a particular ETK called Save the Penguins. Save the Penguins is concerned with heat transfer and thermal energy. Students learn these concepts and then they design and build a dwelling to protect penguin-shaped ice cubes from melting under a heat lamp. The students construct their dwellings from things like cotton, aluminum foil, and construction paper. Each team's goal is to best protect the penguin with the lowest cost in materials. The final results are measured in the cost per gram of ice remaining. The goal in Save the Penguins is for students working in teams to design and build solutions for this particular problem. Because this is a design-based activity, we encourage the teachers to guide the students through the design process, demonstrate the skills the students will need to learn while working in groups, but then let the groups function relatively independently in building their dwellings for the penguins. To construct the dwellings, students are provided with tape, bubble wrap, construction paper, cotton balls, craft sticks, cupcake liners, felt, foam, foil, and mylar. Each team gets to buy these objects with a certain cost for each of them. At the beginning of the exercise, students are given a worksheet to test their knowledge of heat transfer. They're also asked in a group to brainstorm everything they know about heat. This serves as a background for them to design their penguin houses. They are asked to plan the dwelling, sketch it, calculate its cost, and while they're doing this, we give them a series of demonstrations. These demonstrations challenge their conceptions and sometimes misconceptions about heat transfer. In one, a series of 6 soda cans is placed in front of the students. They've all come out of the same refrigerator, they're the same temperature. We put a thermometer in each one, but we wrap each can in a different material and ask the students to predict what can will be coldest after 25 minutes. In another one, students hold a plastic spoon and a metal spoon, silver preferably, with an ice cube on each one, and then they have to predict which ice cube will melt most quickly. So in both cases, they have their previous conceptions about what's going to happen. Something happens, and then they have to address what the consequences are for the design of their penguin huts. The students work in teams to build one dwelling. Then all of the dwellings from all of the teams are put into a cooker, which is a enclosed space with 3 lamps on it, and they're left there for 10 minutes. The masses of the remaining, that is the non-melted ice cubes, are then measured. The students see what the results are for their particular team as well as all the other teams. The students then repeat the process, designing a new penguin dwelling based on their knowledge from the initial task, and they can use these results to improve upon their designs. Students should strive to protect the penguins, but also to be cost effective. After the final houses are removed from the cooker, the winning group is decided based on the final cost of the house and the amount of ice still unmelted. This summer we had a blast at the University of Virginia. Blast was an intense summer experience for high school students focused on science and engineering. The first 2 sessions of Blast involved 160 students and 13 teachers. Blast was a partnership between the Commonwealth of Virginia and the Virginia Space Grant Consortium. The idea and funding for Blast came from Delegate Joe T. May, an engineer, inventor, and businessman. Next year there will be additional sessions of Blast at Virginia Tech and the University of Virginia. For more information, visit the Blast site or the Virginia Space Grant Consortium site at the links shown here. Margot Ferraletto filmed, edited, and produced these videos, and we thank her for all of her efforts and for serving as an intern at UVA this summer.